Hello and welcome to lesson number 4 in Unit 2A of our grade 10 academic math class. This is solving for an unknown angle in a right angle triangle. So we're going to start by looking at some common inverse operations. Now inverse operations we're familiar with, they come from BEDMAS, right? So take a moment, hit pause here and copy down this table into your notes or into the skeleton notes that we provide with our lessons. And once you're done copying this out as much as I have filled in here, then come back and I'll talk you through the rest of it. Okay, you're back. Let's look at the first category here. So we have 3x equals 15. What's the operation happening to x? So what it's asking is what's happening to x here. X is being multiplied by 3. How do we undo that? Well, the opposite of multiply is to divide. And when you work that out, by dividing both sides by 3, you end up here with x equals 5. Pretty familiar, we did this all the time. Let's have a look at the next equation. X minus 7 equals 14. What's happening to x? Well, it's having 7 subtracted from it. What's the opposite of subtracting 7? It's adding 7. So we add 7 to both sides here, and what you end up with is x equals 21. Again, so far so good. This is the MD and AS of BEDMAS, so very familiar to us. This one comes from the E in BEDMAS. If we have x squared equals 36, what operation is happening to the x? Well, it's being squared. How do we undo that? We square root. That's this bad boy right here. We do that to both sides, and we end up with x equals 6. So far, so good. But what we have here is something you've never seen before. It's sine x equals 0.7071. Now, if you remember back to the lessons that we've already completed, this is 0.7071. It is from some reference angle. This is an opposite amount. Whoops, sorry about that. It is some opposite amount being divided by some hypotenuse amount. When you actually do that calculation, you've ended up with 0.7071, and that's fine. What's unique in this case is that we've been given two sides, and what we don't know is x. So what is happening to x currently? There's no nicer way to say it than to say having sine taken. There's not really a nicer way to say that. So we're having the sine taken of it, I guess would be the proper way to finish that up. So it's having the sine taken of it. So how do we undo that? What is the division to its multiplication, or the subtraction to its addition, or the square rooting to its square root? And it is called taking inverse sine. Now inverse sine sounds pretty crazy. Hard to figure out what that is, but here's how we write it. What we essentially have is I'm going to write it in a slightly different way here than I might otherwise. So we have the sine of x, and we have the sine -1. And that's the way of saying the inverse of sine is going to be equal to the sine -1 of, whoops, that was too big, 0.7071, I think it was. Now this is something that you can rely on your calculator to complete for you, because taking the sine and the inverse sine of something, essentially they've canceled each other out, they've undone each other, and we're left with x is equal to approximately, and now we're going to type this inverse sine into our calculator. Now I'm just going to do it right now so I can get the answer. So we're going to have the inverse sine of 0.7071, and it's going to give us 44.999. So we're going to round that, as we will with all angles of rotation unless otherwise stated, to the nearest whole degree of rotation. So that's approximately 45 degrees. So there is a way to undo taking the sine or taking the cosine or taking the tangent of an unknown variable, an angle of rotation. It's called taking the inverse sine, cosine, or tangent, depending on what the primary trig ratio is you're using. Let's see how to do this. We're going to start by just giving you a new piece of information. This little symbol here, and you can see it's hiding down here in this triangle. That little symbol is a Greek symbol. It's called theta. That is one that we often use when we're finding unknown, or that we're leaving in the place of unknown angles of rotation. Just so when you hear me saying theta, you'll know that I'm talking about an angle of rotation that is unknown. So let's jump to this triangle right here. What we have is sort of the bare bones of the Sohcahtoa setup again, which is helpful. So there is our reference angle, our unknown theta. So let's start by coloring that in. And let's look at the sides that we have here. So the sides that we have are across from our reference angle, we have our opposite. and across from our 90 degree we have our hypotenuse. So we are going to be using opposite and hypotenuse. So sorry, cosine and tangent, we're going to be using sine. So what I'm going to write out is the 3-variable trig ratio, but I'm going to be leaving out for the first time the angle of rotation, which we don't know. And I'm just going to pop a theta in there. And it's equal to the opposite side, which is 4, over the hypotenuse, which is 7. Now at this point, we're going to type in sine -1 into our calculator because that's the only step left for us in order to isolate our angle theta. So what we want to do, I'm going to write this in a slightly different way now. I'm going to say that angle theta is equal to the sine -1, which is how we say sine inverse, of 4 over 7. There's no need to do that calculation just yet. We can do the whole calculation in one fell swoop. So where do you find this? On your calculator, most likely, you'll see the sine button, and the second function, or shift, i.e. accessing the information sort of written above the sine button, will likely have a sine -1, and above cos will be a cos -1, and above tan will be a tan -1. You just have to figure out how it best goes into your calculator. On my calculator, what I type in is second function sine, and what I see in my display is this part right here, sine -1. And then I'm going to open a bracket and type in 4 divided by 7 and close the bracket and hit equals. And I am left with approximately 34, or I'm left with 34.84, so I'm going to call that 35 degrees. Again, we're rounding our angles of rotation to the nearest degree. So that's how you do it. That's how you tackle it. Let's go have a look at B. So B, same thing. I'm going to start by identifying my angle, my reference angle. There it is right there. So from my reference angle, I have 8, which is across from it, so that is my opposite. And then I also have the one beside my reference angle, so that is my adjacent. So which trig ratio should we use here? If you said tangent, you are correct, because we have both opposite and adjacent, so we're going to use that. Let's start by writing this out. So we have the tangent of angle theta is equal to the opposite side over the adjacent side. Now how do we get to angle theta? As before, we're going to find angle theta by taking the inverse tangent of 8 over 9. And again, just to explain it a little bit, essentially what you're doing when you're finding the inverse tangent is, back in the day when they were developing trigonometry and working through this, they were finding all of these ratios for particular angles over and over and over to increasing degrees of specificity. So very, very detailed tables. When you're asking your calculator to do the inverse tan of 8 over 9, what it's asking you to do is find for which value of 8 over 9 is tangent's angle appropriate. That's what we're really looking for. So what your calculator is doing, unlike making calculations, it's actually just going through a whole bunch of tables and finding the piece of information that you want. So what we're asking our calculator to do is look through the tables. When you divide 8 by 9 for tangent, which angle does that come from? And that's what we're going to get our calculator to do right now. So I'm going to type in second function tan, which in my display gives me tan -1. And then I'm going to type in, open a bracket, 8 divided by 9, close the bracket, equals, and that gives me 41.6. So angle theta is approximately 42 degrees. All right, I think we're going to be able to make it here in one video, so let's just press forward. There's triangle C right here. We've got our Sohcahtoa pop it in there. We have our angle of rotation. Let's just tidy that up a little bit. Let's see what sides we have. So we have here our hypotenuse, that's across from the 90, and we also have our adjacent side right here. So which trig ratio should we use? If you said cosine, you are correct. We have adjacent and hypotenuse. We don't need sine or tangent. Let's start by writing that out. So we are going to write out the cosine of angle theta is equal to the adjacent side, which is 7, over the hypotenuse, which is 12. So how do we get to angle theta? We perform the inverse cosine, or cos -1 of 7 over 12. And again, you don't have to do that 7 over 12 calculation. In fact, I would prefer if you didn't, so that we can get it right here at the end. So what am I typing in? Second function cos, and in my display, I see cos -1. I open a bracket, I type in 7 divided by 12, I close the bracket, I hit equals, and that gives me 54.3, so we're going to call that 54 degrees approximately. All right, one more example to go. Here we have a fourth and final triangle. Let's get our reference angle colored in. There it is. So from our reference angle, we see here we have the hypotenuse across from the 90 degrees, and we have the adjacent, which is beside our reference angle. Which trig ratio should we use here? Again, we have adjacent and hypotenuse, so this is going to be another opportunity to use cosine. So let's write it out. We have the cosine of angle theta is equal to the adjacent, which is 21, over the hypotenuse, which is 24. And I'm going to get to this angle by taking the inverse cosine of 21 over 24. And again, just to reiterate this, your calculator is not actually doing a calculation. It's looking through trig tables, which is how back in the old days, before the internet and before such wonderful calculators and computers, people would actually look for this value. So they would do 21 divided by 24. They know it's a cosine ratio, so they know it's an adjacent side divided by a hypotenuse, and then they're looking through this table to identify the correct angle that has 21 divided by 24 as that value for cosine. So we are going to just luckily type this into our calculators. No need to look through our trig tables. I'm starting with second function cosine, which gives me this little value in my display. I put in a bracket. I type in 21 divided by 24, close the bracket, equals. And that gives me 28.9, so we're going to call that 29 degrees approximately. And that is our lesson on finding angles in a right angle triangle using primary trig ratios. Now, some of you might be having trouble deciphering your calculator. That's an understandable thing. If you're having trouble with the calculator, like if you're following along perfectly but you're just not getting right answers, it might be that your calculator is not set in degrees. Could also be the way that you're typing the values into your calculator. So reach out to me via email, talk to me in person in class, or we can connect online some way, somehow. We got to make sure that you know how to do this. This is one of those skills, trigonometry, all the stuff you're learning, you're going to carry this all the way through to grade 12. So it's important that you master it. Good luck with the homework, and I'll see you in the next lesson.